the tangent function. So in this video, we're going to talk all about the graphs of tan, y equals tan x. So the key thing about the graph of y equals tan x is that tan, we can't forget tan equals sine over cosine. That has a huge effect on our graph here. Right, so first, like, how do we find our zeros? Well, zeros are when sine equals 0. So whenever sine equals 0, which is at 0 and pi and 2 pi, tan doesn't equal 0. You can see that on the graph here. At 0, sine 0. Tan 0, I should say. How about these dotted lines here? These vertical asymptotes, right? That's where it's undefined. Well, when is tan undefined? When are you undefined? When you can't divide by 0. So anytime cosine 0, tan has no value. You can't divide by 0. So that's why it's undefined wherever cosine 0, which would be pi over 2, 3 pi over 2, right? If you think about the units directly relates to that. Let's talk about some properties of this tan function. So if you notice, just like sine and cosine, it's periodic. It just keeps on repeating itself. So like, I'll kind of consider this the primary tan function, the one, right? Kind of looks like an x cubed graph, but just keeps on repeating and repeating. You notice that the period for one of these guys, goes from negative pi over 2 to pi over 2, or a full pi. That's different than sine and cosine, right? It's not 2 pi. So a basic tan function has a period of pi, not 2 pi. And then our amp is 1. That has less effect. It's kind of like an x cubed graph. It's kind of the slope of this line. The bigger the slope, the more straight it gets. The less the slope, the more kind of curvy it gets. And then like any other graph, you can move it up and down, left and right. So now we can talk about the generic function. Like I mentioned, right? You can move it. You can have a principal axis at D, like everything else, vertical shift. You have a horizontal shift at C, or a phase shift at C. But A and B is where it's fun, right? The period is pi over B, not 2 pi over B. So it's a little different. And then amplitude is kind of undefined. It's just kind of how straight your function is. So let's graph this one. Just so we get some practice. So it's here, the key thing is find out the period. So in this case, it's pi over B. My B here would be 1/2. So that'd be pi over 1/2. Also known as pi times the reciprocal of that, which would be 2, so 2 pi. So that'll be my period. Let's do a basic graph. Let's just go, we're going to go pi over 2, pi, 3 pi over 2, 2 pi, and then let's go descending this way, negative pi over 2. Let's just go down to negative pi, I don't want to go too far. Now, so the key thing with the tan graph, it starts in the middle. Like a basic tan graph looks kind of like an x cubed graph, right? Where from here to here is the period, which in my case is 2 pi. So if I was graphing it here, right, we're going to go from here to here. The whole span should be 2 pi. So that means we're going to go from here to here should be 2 pi. We're going to go pi in each direction. So my asymptotes are going to be here and here, right? Again, so the period's 2 pi. So that means that if I'm starting at the middle here, I gotta go half of the period each direction. So I'm gonna go pi this way and pi that way. Other than that, it's a normal graph. It just kind of looks like an x cubed graph. Kind of looks like this. I'll do the same thing here, right? If I started pi, I have to go all the way actually to 3 pi would be where my period ends. But I only have half of that, so I'm just gonna do this bottom half of it. This would have been the top half. And that's how you do a basic tan graph. Without using technology, sketch a graph of y equals tan of x plus pi over 4 from 0 to 3 pi. We'll do it without, then we'll do it with this for a quick second so you can see it. So this one, if you notice, it has a phase shift or a horizontal shift. So inside opposite, we're going to go negative pi over 4. Now we might not go all the way to there because that's going to be much, but we'll just kind of start and see where we go. So that's there. So 0, they want to go by pi over 4. So I'm going to go back negative pi over 4. Let's make this pi over 4. If you go another pi over 4, that'd be pi over 2. And then 3 pi over 4. Let's go by over 4s here. And then that'd be pi. And then I can keep on going. But I think, let's go just a little bit more. Just to make sure. That'd be 5 pi over 4. Just count by 4s. And then it'll be 6 pi over 4, which is 3 pi over 2. I think there I'll stop just for... I don't want to keep on going, but stop there. Now remember the way this works, since I started negative pi over 4, that's where we're going to start. That's right, my graph would start there. Don't forget tan looks like this. But from there to there is my period. Well, remember the period for a tan function is pi over b. actually don't have a b in this case. So it's be pi over 1 or just pi. So if I start at negative pi over 4, I got to go pi in each direction. I got to go from here to here will be pi. I got to go half pi each direction. So that's why tan's weird, because this is half your period and half your period. That's the way I like to think about it. So if my period's pi, that means I'm going to go pi over 2 each direction. So if I start at negative pi over 4 and I go pi over 2 each direction, it'll be like about here. Right? Because this is pi over 4 plus pi over 4. So we're going to go about here. Then if I would go back, it'll be like negative 3 pi over 4 over here somewhere. So if I start there, once you have one isotope, the rest of it's actually a lot easier, I promise you. Because we know where we're starting. We're starting at pi over 4. Now all we gotta do is add the period, which we figured out was pi over 2. Pi. And we add the common denominator, so 4 over 4. So right, what we talked about before. So we usually start plus the period to figure out where you end. In this case, we get 5 pi over 4. So that'll be the end of the this rotation, about 5 pi over 4. So if you want to find the midpoint, same way you find midpoint of anything, you add pi over 4 plus 5 pi over 4 and divide by 2. Or for ease, it's to the tops. Pi plus 5 pi would be 6 pi. Divide by 2, 3 pi over 4. So this will be my middle. Right, and if we're graphing tan, it's just a basic tan graph, so it's going to look kind of like this. And like that. Don't touch the asymptotes. Standing over here. Now if I actually want to follow this, I'm not going to start at 0. We're going to start is at, we want to go from 0 to 3 pi. So it's actually be kind of like this, and then you got to kind of stop, because we're not going to, you can't go, you want to start at 0. And then technically I should go all the way to 3 pi, which would be another graph over here somewhere. But for there, I'll save you, so we don't have to go through all that stuff. So that's how you graph it without a calculator. So you sketch it by hand. Now let's talk about how to sketch with the calculator so you can see what it actually looks like. Pretty simple. First, we want to make sure we're in radians. We're going to graph it with one being radians. So I'm going to turn my thing on. I'm going to go to mode. I am in radians. I'm going to go to y equals. We're going to write tan of x plus pi over 4. So we're going to hit tan, parentheses, already on, x plus pi over 4. Second, pi divided by 4. Now, I'm going to hit graph, and you can see what it looks like on a center graph, right? It's all good and great. But don't forget to fix your window, especially if this is on a quiz or a test. You want to make max window to give you. So I'm stopped it earlier. I'm going to go to window. I'm going to go from my x should go from 0 to 3 pi. So literally just type that in, 0 to 3 pi. So 3 and then pi. It'll change it to decimals right after you press it, but that's great. When I do sine and cosine, I'm going to watch out for the y min and y max. Like you find the min, the max, all that stuff. For tan, it really doesn't matter. They go on forever. So negative 10, 10 is fine. Let's graph this. And we get something that looks like that. Right, so that's us right there. That's the first part. Again, I didn't go all the way to 3 pi because I was lazy, but that's the way it looks. That's how you do it in the calculator. Let's do one more of these. Then we can call it a day. Without these technology, just sketch the graph of y equals tan of 2x from negative pi to pi. So first thing I like to find is the period. 2 pi over 2. Sorry. For tan, it's only pi. So pi over b, which would be pi over 2. So that's my period. Now remember the way tan works is you actually start at 0, 0. And you go half the period each direction. Like from here to here is the period. So you go half the period each direction. Half of that would be pi over 4. So you can go pi over 4 right and pi over 4 left. So let's say this is pi over 4. I'm going to go right that direction. Then I go back pi over 4 the other direction. Right, because my period of pi over 2 is this whole thing. All of this is pi over 2. And then we have pi, and then so that makes halfway pi over 4, pi over 4. Again, if I want to go all the way to pi, well, I'm at pi over 4. If you want to figure out what the next rotation is, just add the period, which in this case is pi over 2. Common denominator. So I get 2 pi over 4 plus pi. I'm getting 3 pi over 4, sorry. So that's pi over 4. Let's say this is 2 pi over 4 and 3 pi over 4. 4 pi over 4. Because it wants to go all the way to pi, so like 4 over 4. Again, end of my rotation, my first asymptote was at pi over 4. You add the period, which was pi over 2. And you end up with 3 pi over 4, common denominator. So I'm going to end right there. We can do the same thing going backwards. We're at negative 3 pi over 4. Then we subtract off the period, which is pi over 2, common denominator. And we get negative 3 pi over 4. So it's like negative 2 pi over 4, negative 3 pi over 4. If we're going all the way to negative pi, we negative 4 pi over 4. This is where my asymptote should be. So yeah, so now it looks like this. All we do now is graph it. It's a tan graph, right? Don't overthink it. Start at the middle, kind of like execute graph both directions. Start at the middle, halfway point of pi over 4 to 3 pi over 4 is going to be 2 pi over 4. Now remember, I got to go all the way to pi. Right, that was my domain. So I got to do this little part here also. That would be the halfway point to only this part. Then sitting on this side, halfway point. And halfway point, but I can only see this half of it. And that'll be the graph. And again, it's just a sketch. It doesn't be perfect, but that's the general idea. And that's our graph 10.